Hello, welcome back, guys. Welcome back, and yeah, so we'll be discussing some estimation problems today. And since we have completed the ideas of estimation in our previous classes, I think it's the best way to start. Just give me a minute. Yep. So let's get started. In estimation, we are planning to do some UMVU problems as suggested by Nikhil. So what about Polami and Shuprabha? Anything you want to share? Anything you want to share? No? Okay, fine. Okay, so how is the preparation going on? Anything? So, okay, regarding UMVV, okay. So, do you remember that I told last day that how to find an UMVV? So there are two algorithms to find an UMVV. The number one algorithm that we do is the following. The two ways of finding UMVV. The number one way of finding UMVV is by using CRLB, right? And the number two method is by complete sufficient statistic, right? So how do we do it? The CRLB method is the following. We find out the CRLB. So let's say we want to find unbiased estimator of G theta of G theta, okay? UMV of G theta, okay? And the first step is that find the CRLB of G theta. And while you're doing del L del theta, okay, like sorry, log of f theta x curl. When you're doing that, if you remember that it would come in this format: a theta times some theta hat minus g theta. If this is expressible in this format, then theta hat is UMVV of g theta. Did you understand this, guys? Nikhil, Paulami, Suprabha, Mansi. Yeah, we have done this a lot of times.
Yeah, this is fine.
Okay. Follow me? Okay, good. Perfect. So this is by serial B only that we do. And yes. And the next one is by complete sufficient statistic. Complete sufficient statistic. So what we do over here is that,
Can you show the previous slide 1 minute just checking something?
sure, sure.
Yeah, please go ahead.
And the second one is first, let's say also find the aim is g theta to find EMV of g theta. So what you do is that you first find a CS, okay, or let's say you want to find G theta hat, or let's say T. T I write CS. I write CS. CS means complete sufficient, okay? So by that I mean that TCS is complete sufficient, okay? And what we expect it to be is that TCS is a complete sufficient statistics of theta, of G theta. Okay, and what we need to do is the following: we need to find another unbiased estimator, U, which is a function of TCS, such that expectation of U is this. Okay, expectation of U is this. And what will happen? This will lead to the fact that by Lehman-Schiffer lemma, U is UMV of G theta. Now the question is that many times this is not easily like you cannot easily do it. Why? So how to find that U? That is given by Rao-Blackwell theorem. So there are two ways to find an U. Okay. So you find TCS, complete sufficient. You find the TCS, the complete sufficient statistic, and what you know is that this TCS, you know the behavior of TCS. For example, let's say if you find expectation of T, let's take normal theta comma normal mu comma sigma square, and you know that sigma square के लिए TCS is nothing but 1 by n summation xi minus x bar whole square. But you know that this is not unbiased. So you find a function of TCS which is unbiased, right? So it is easier to do in that sense. Okay, and you do it to 1 minus n, you multiply it by this. Okay, so you tell that it's n by n minus 1 times TCS. You find that. Okay, and then you tell me that since this is the case, you can tell by Lehman-Schiffer that this is a UMVA. Okay, since it's a function of complete sufficient statistics of sigma square. But many times it's not possible. So this is one way. You easily find it. One way. Another way possible is this. You find TCS and and you find out U1. Oh, you find out E1, any unbiased statistics of G theta. Any unbiased statistic. And what you do is that you find expectation of U1 given TCS. This is the Lehman-Schiffer step, right? The Rao-Blackwell step, right? With this ISCA variance is becoming less, and by the uniqueness property, this will be the UMVV. So if there are two algorithms. This is the harder way, you have to calculate more. This is an easier way when you try to find it easily. Okay, that's it. So these are the two steps. These are the only two steps that you can do. The main idea is that this is also a function of TCS actually. It's also a function of TCS. So essentially, your idea is to find a function of TCS, that is the complete sufficient statistics. CS means complete sufficient statistics. That is a function of which is unbiased estimator of g theta. The rest will follow. Okay. Did you understand the algorithms, guys? These are the two algorithms. Okay. Very good. So now we'll be applying this. These are the only two methods. Okay. Now we're applying this on problems. So last day I did a problem from uniform theta. Do you remember that, guys? Or binomial 1 comma theta, Bernoulli theta. Did you remember that? Do you want me to repeat it again, guys? Yeah. Last day while ending, I did a problem from there. Okay, so let's do this. So we will be finding the UMVV of this. So what we need to do? We need to find first show that this is the complete sufficient statistics for exponential theta comma 1, and then this is the location theta. Okay, and then you have to show that the UMVV of g theta is theta square. So find the UMV. So you have to find complete sufficient. That is, you have to first step is to find TCS. The second step is to find a function of TCS, which is an unbiased estimator of theta square. Theta square is there, okay, not theta. So how will you do it? Okay. So how will you do it? So we have to follow the second rule, that is using complete sufficient statistics, and let's do it step by step. Number one step, finding the complete sufficient statistic. So you can easily understand that this is dependent upon, like the support is dependent upon theta, so we cannot use exponential family. Okay, to express it, right? Do you agree with this, guys? Do you agree with this? Do you remember this? It cannot be expressible as exponential family, one parameter. Yeah, all of you. Do you know that in a one parameter exponential family cannot, like, is not dependent upon the support is not dependent upon theta on the parameter? Yeah, yes or no? Good. So that is a very important aspect. So we cannot use the OPEF result that and use it to find a complete sufficient statistic. So we have to use something else, and this will be interesting. Let's see. So let's do the sufficiency part, and can you guess a good estimator that we can be sufficient? Can you guess from this? So you should be learning this now. Can you guess from this what should be a good sufficient statistic? Any ideas? Any ideas? What can be a good sufficient statistic? Yeah?
Sir, X bar,
क्या क्या?
X bar are mean.
X bar, okay. So what do you do in case of uniform, where x is less than theta? So the condition is that, understand this. Let's try to find the MLE. So I'm trying to find the MLE is that MLE is usually sufficient. MLE is a function of the sufficient statistic. So MLE usually sometimes have, like, easy to understand. If you find the MLE, let's find the MLE. Can you find the MLE, guys? So find the MLE, we need to find the log light. Anyways, we need to find the likelihood. So let's find the likelihood. Let's find the likelihood. It will turn out to be what? Product of e to the power minus xi minus theta. Indicator xi is greater than theta, right? If we write it down, we get e to the power minus summation of xi minus theta. Indicator, all of them is greater than theta. And what we get over here? E to the power n theta times e to the power minus summation xi into indicator, all of them is greater than theta is what? That means the minimum is greater than theta. X1 is greater than theta, right? So this is what we get. And can you now tell me what will be the MLE, guys? X1 greater than theta, and can you now tell me what will be the MLE? It's very easy now. This is the theta, and this is the, yeah. So tell me now, what should be the MLE? I think, am I doing some mistake? Am I doing some mistake? Um, just give me a minute. Am I doing some mistake? Yeah. So tell me. Yeah. 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 Go ahead. Go ahead. Yeah. Oh, yeah. I did some mistake, of course. So here, the mistake is the following. Here, theta is actually less than x1. So this will be x1. It's less than x1 and less. So theta is less than x1. And therefore, you can see it's an increasing function. So e to the power n theta is like this, and see the maximum is happening over here. So MLE is the minimum order series. How did I understand it from here? You can easily understand. Usually, in this case, the best way to understand is that if all xi is greater than 0, the minimum will be the MLE. You can easily understand just from this expression. Okay, usually it will be the MSE. It happens usually, almost all the time. So you can get an idea from there, and I got an idea from there only. Also understood this, how the MLE is being computed. Yeah. So this is gonna give us an idea. Okay, maybe for uniform 0 comma theta, like a maximum order statistics is a good estimate of, it's an MLA, also a sufficient statistic. Maybe also here xn can be a good sufficient statistic. So x1. So let's write it down. So let's write it down. Number two is sufficiency. So why I told you is that to improve your intuition about statistics, which is important for the exam also. Also, like quickly understanding something, that okay, this is something happening. So here f, that's also the first step. Fx curl is equal to e to the power n theta times e to the power minus summation xi times indicator x1 greater than theta. So remember my nft, name and factorization theorem. What was that? Can you tell me what was that? Nft, what we need to do for nft? Yeah. NFT, what does NFT say? NFT says that The likelihood can be written as in form of h of x times some g of the sufficient statistics, comma, theta, right? So this can be written as h of x, that means this, times e to the power n theta times in it this. You can really understand that this is of the form what? This is the h and this is the g of x1 and theta. From here by NFT we can say that x1 is also sufficient. Okay? This is what you've got. This is algorithm. All the algorithms I have shared with you. Okay, this is very easy. All the algorithms I've shared with you. The next one, the completeness part. How do you find the completeness? See, I don't know what is the completeness, but I will do it from the first principle because I have no intuition about the completeness. Okay, I'll do it from the first principle. First principle is always easy. Always first principle is easy. First principle. So, what is the complex? What is the completeness? So, it's expectation of. So, g of t is equal to 0. G of t is equal to 0 implies g is equal to 0 on the support of t. Remember that support of t. So ah, let's compute that by using Lotus. So therefore, you have to find out the distribution of t, right? For that, we need to find the distribution of t. Let's compute the distribution of t over here again. That is x1, whether it's complete or not. So the distribution of t, so we'll add a thing over here. You see the steps, it's very logical, okay? I'm not doing anything very hard and fast. Yeah, you're right, Mans. Actually, I couldn't see the. You're right, Mans. I couldn't see the your answer previously because of my screen. So that's why I couldn't reply. I'm sorry. So therefore, you need to yes, you understand that you need to find the distribution of t. If you don't know, so to find distribution, let's apply order statistic. All the things you see, I've learned till now. See, this is a step where you will have to understand. Okay, you are doing it correctly. The next step you have to do is that you have to do it, you know, really, really fast and quick. That's where your exam wala preparation will come up. So how to find that? It's very easy. So the distribution of t is, I'm again to a first principle, f of t. So that means x1. X1 means, let me do it for the first principle. Here is x1. So out of the n options, you have to choose the x1th position, that is this. And this is the case, then all of them, all of the rest of the ones, n minus 1 will be greater than this, right? So probability, all of them is greater than x1, that is t. So it's 1 minus fx of x whole to the power n minus 1 times, for that, this distribution के लिए, just f of x. So we get that n times this will be running out to e to the power minus x minus theta. You can understand that x must be greater than t must be greater than theta, okay? This will be t, sorry. Yes, so this is also t. So also integration of this will give rise to what? Can someone tell it to me? Theta to infinite, theta to t, e to the power minus x minus dx will be turning out to be, anyone? 1 minus e to the power minus t minus theta. And you will see it's 1 minus 1, so e to the power minus t minus theta whole to the power n minus 1 times L minus 1. This is what you will get over here, right? And yeah, so now we have got the f of t, the orders, the distribution of this, and so this will be also t. So you get what? It's n times e to the power minus n t minus theta. This is what you have got. So let's replace this over here. So therefore, it will be integration theta to infinity t times this n e to the power minus n t minus theta is equal to 0. This is what you have got, right? Sorry, there's a problem. It will be gt over here. Sorry, gt times n e to the power minus n t minus theta dt is equal to 0. So let's do something interesting. So you see, this is a function of, so this is our theta t. Okay, so what if we, so you can see it's a function of theta actually. It's f of theta, some f of theta. So what I will do is that since f of theta is equal to 0, this implies it's got different derivative also 0. So d theta n times theta to infinity gt e to the power minus n t minus theta dt is equal to 0. So if we do the derivative over here, okay, so let's see. So why we can do the derivative? Just because, why we need to do derivative t? Because theta and t are, opposite. They are not dependent. They can be interchanged. And this is something, yeah, it's very important for this. So if you do d theta, dt, if you remember, you
I didn't
understand?
understand this differentiation where it came from. Can you please
Sure.
explain?
So the idea is that this is a function. If you just compute without this, okay, just this, let's not take it equal to 0. So if this is a function of f of theta, right? If you observe, it's just a function of theta, right? Right? Let's not to look at the right hand side. It's just a function of theta, right, Nikhil?
Yes.
And also g. So if this is a function of theta, so we are just differentiating d theta f theta. Since it's 0, we can tell that it's equal to, uska derivative is also 0. We can tell that now. So why we are doing that? Because from here, maybe we can get something about g. Maybe we can get g theta equal to 0. Okay? Did you understand? Did you understand? Huh? Nikhil? Hello? Am I not audible? Hello, guys? Did you understand this, Nikhil?
Yeah.
Okay, okay, fine. So let's do the derivative of it. And if I hope you remember that, um, I hope you remember this from the aspect of what should I say? From the aspect of fundamental theory of calculus. So this is nothing but, if you do a differentiation, it's nothing but t tends to infinity over here. Okay, if t tends to infinity, it's like this. So let me just write it down, the mathematics of it. So let's say it's like this integration 0 to infinity, right? Some if some let's say mtdt. Okay, so it can be written as if, so if we calculate it, if we calculate the indefinite, it's m infinity minus m theta, the indefinite integration. Okay, so I mean, if I can write it as where mt mz is equal to nothing but theta to um, t. Okay, and theta to z of this small mt, just like the cdf and just like the integrand. And there's a result that if this is this, then, and if you call this, let's say n theta, then n dash theta is nothing but what? It's nothing but m infinity minus m theta. Okay, that is a result of Leibniz. And using this, we can show that if you put it my infinity over here, it's minus infinity, right? So it goes to zero. So that doesn't matter. So we get that it's minus of theta over here. So it's g theta e to the power minus n times theta minus theta. That is 1. It's minus g theta is equal to 0. And therefore g theta is equal to 0. And g theta is equal to, for all the values of theta, there is no restriction on theta over here, though. I think it should be written. There's no restriction over theta, so it can be anything. So hence, if you put various values of theta, it will get various aspects of g is equal to 0. So hence, we get that g is kahan gaya? Hence, we get that g is 0 on the support of t. Also, did you understand, Nikhil, guys? Nikhil and others, did you understand how I solved it? Usually, the two ways for discrete, we get polynomials and we compare the coefficients of polynomials. For continuous, we usually do it by um, integration. So this is how we usually do it. For discrete, we use polynomial coefficient comparison, or OPEF, one parameter exponential family one. And for continuous, we use this differentiation method. There's also something called, a Fourier transform and stuff like that, but Laplace transform, Fourier transform, but we don't want, like, you will not be required to do that. So differentiation. And yeah, differentiation, like d theta of integration, that. So that will lead to g is equal to 0. So, and also PEF. So polynomial coefficient comparison and this differentiation are the two usual methods outside this, and we can show it by that they are complete. Hope you got it, guys. Did you understand? Did you understand, guys? Okay. Others, Nikhil, are you sure, Nikhil? Is it getting better? I don't know. Like, okay, is it become more clearer?
Yes.
Okay, great. So this is a basic idea, and therefore we get that what? Therefore we get that you see the like step of the steps we are doing. It's like I am doing the full steps. Okay, the full steps of this problem. So we get that this TCS is nothing but x1. Okay, so now a small result that you can use is that if t is complete and sufficient, I can write CS for theta, then does it imply that TST is complete sufficient for any g theta? Is it true, guys? What do you think? Is it true? If t is complete sufficient for theta, is t complete sufficient for g theta? So let's try to prove that. So let's do the completeness part. So expectation of t is equal to 0, gt is equal to 0, implies an expectation of, that is, g is equal to 0. So where is the use of theta over here? Tell me. Where is the use of theta over here? So actually hardly any dependence about theta. So it's of course any complete for g theta, okay? And sufficiency is also the same. So if it's, so what is the definition of sufficiency? The distribution of t given x this of small x curl t is equal to t is independent of theta, right? If it's independent of theta, it's also independent of g theta. So if t is complete sufficient for theta, it also shows that t is complete sufficient for g theta. It's very, like, it means that if t has all the information about theta, so therefore t has all the information about g of theta. It's very simple to understand. Did you understand this small subtle step, guys? This is very important. This is a very important step. Did you understand? It's also intuitive. Okay. Are there any other doubts? Did you understand, guys? Nikhil, Paulamy, Froma. Okay. What about Paulamy? Did you understand this? Very good. So now we have got that TCS is complete sufficient for G theta. That is done. What else? The other thing that we really need is to show that, to find a unbiased estimation, find an unbiased estimator that is a function of TCS, that is a function of this, that is a U. So we can do it in two different ways. But the easier way is that let's find out x1. I don't know. It feels like if we find out x1, the expectation of x1. We don't know the expectation of x1, right? Let's find out the expectation of x1. It may be easier that way without conditioning. So let's find the expectation of x1. That may be an easier step. So if you find the expectation of x1, so if we find an expectation of x1, so we have found out the distribution of x1 over here again, and we have found already the distribution. So let's find the expectation of x1. So it's theta to infinity x or t n times e to the power minus n t minus theta dt. Okay, this is what we have got till now. And if you observe it, then you will get that n. So I hope you can understand. We can replace t minus. So let's try to do something out here. So okay, so can you just compute it, guys, right now? It will be a good practice. Right now, please compute it and tell me the solution of this integration. I will wait. I will give you 2 minutes. Why I'm talking too much? Please do it. Tell me right now. I'm giving 2 minutes to compute it. Share it in the comments or whatever. Let's do it. Yeah, in the meantime, if you're liking this video and this discussion, please do like, share, and with your friends who are really looking for this and will be needing this. Thank you for your time. And yeah, and also please do the solution of this integration and do let me know in the comments. Yeah, so we need to find out this expectation because maybe I think you can find out theta square over here. Maybe not, maybe yes. So let's find out. Who knows? But that's the easier way out because why? As I've told in this step over here, is that this is one way, this is another way. So this is step number one, this is step number two. So we are trying the easier way out, we are trying then the harder way if it doesn't work that way. This is exactly how I use what algorithm I use to solve a problem. And yeah, that I think is really useful for the students out there. Need to do this calculation, guys? Mansi, Nikhil, Paulami, Rajesh, Nikhil, Proma, Shuprabho. Yeah. So you're doing the integration, guys? Any leads to the solution of this integration? Yep, Nikhil, Mansi, Paulami, Proma, Shuprabho. Any leads?
I am getting theta n plus 1 by n.
Okay, very good. So theta n theta by sorry, this one.
Yeah,
Okay, others also got this. Yeah, others also got the solution of this integration. Guys, you are in like 2 months are left for IIT JAM, and if you can't solve an integration within 5 minutes, that's a really bad news for you. So please tell me the solution. That's really bad news. Okay, so Shantanu has told that it's theta plus 1 by n. Very good. Thank you, Shantanu. Yeah, so I'm telling you to Mansi, Nikhil, Mansi, Paulami, Proma, and Shupro, please take it seriously, okay? So you have to do it faster. Integration is the faster stuff. Don't take it light, and I expect you to come to class sitting with a copy and a pen, and just not with your mind. Perfect. Thank you, Shantanu and Nikhil. And let's move on since there are two data. I think it's correct. So n theta plus n. So you can understand that we can get um we you can get something like this, an UMV, so an unbiased estimator for theta but not theta squared. Okay, so we have got that expectation of x1 is equal to what? N theta plus 1 by n, and this turns out to theta plus 1 by n. And you can easily understand that expectation of therefore x1 minus 1 by n is theta. So we can tell that x1 minus 1 by n is UMVV of theta, but not theta square. Remember that. It's an UMVV of theta, but not theta square. Okay? So you understand, to find theta square, maybe you have to find the double derivative of it. You have to find the double derivative of it, maybe. Then you will get something like theta square. We can try it out, okay? That's the best way. So let's try it in two different methods. But the like trickier part is that you have to find an unbiased estimator of theta square. So you have to start from there. So anyways, you have to find something related to theta square. You understand the trick. So here in the next step, in this, you have to anyway start with an u1 which is an unbiased estimate of theta square. Otherwise, you cannot go to that step. And here also you have to find a function of theta square. So essentially the same computationally hard work. Okay. So we have to do it. So therefore, so you can understand, if x1 is around theta, it gives an idea about theta, then x1 ka variance will be given an idea about, or x1 square ka will give an idea about theta square, right? That's an intuition. So the fuzzy logic that I'm using here is that if x1 give an idea about theta, then x1 square will give an idea about theta square. And we have understood that expectation of x1 minus 1 by n is theta. So what we will do is that we will calculate expectation of x1 whole square. And again, integration is coming up and you have to calculate it again. I'm not going to allow casualness over here. Not at all. It's IIT JAM is very soon. So let's compute this again. Okay? And compute this and tell me how to find it. Tell me. Tell me the solution. Tell me the solution, guys. Shantanu, in the live, please do the problem of this integration, and others, please do it. So are you guys like, I'm not sure, like Mansi, Polami, Proma, and Shubra, are you facing problem in integration also?
Sir, you haven't written n in that e power thing.
Oh, yeah. Thank you. So are you guys facing problem in integration, guys? Okay. Okay. So I'm giving you some time, take it. Okay, so it's okay to do a sign mistake, Polemy, but tell me the solution at least. Otherwise, how will I know that which people I need to talk to and give them extra guidance? Like if they are, you're understanding my motive. My motive is to understand that how much time you're taking and how to help you out. So if you are doing wrong, it's fine, but you're at least calculating it. I'm trying to understand the position of you people. So why you are getting like, fearful about making a mistake? That's the worst thing to do. The fear of making a mistake is the worst fear in your life. It's okay to make a mistake. Many times happened that I couldn't do solve a problem in class. It's totally fine, and I teach you. I am a teacher, and it makes sense that you can also make a like a mistake during class as a student. That's totally fine. Anyways, please do it. So how will you do? How you're doing it? Are you doing it by how you're doing it, guys? Tell me. Are you doing it
Sir, by parts
by
is the
parts?
only way.
Yes.
It gets too.
Yes. So you have to do it. It's I know that. So yeah, do it. So yeah, actually, I wanted to calculate the variance of x1. Shantanu, you're right. So how do you know that variance of x1 is 1 by n square? Actually, I wanted to calculate in that one.
And
So
so other than doing by parts, can we substitute that exponent power and then we get a gamma integral?
yeah, of course. So of course. So please do that way, but do it. Do it. So Shantanu, like I was asking you, you're right, but how do you find out this variance of x1? That's my question. So I'm getting something like this. X, I'm getting something like this. Theta square plus. Can you please mute? Yeah, Nikhil Bolo. You want to say something?
Yeah, so theta square plus 2 theta by n
Very
plus 2
good.
by n square.
Plus.
2 by n square.
Are you sure? Yeah, 2 by n square. Perfect. Perfect. This is exactly what I'm getting. Okay, guys. So yeah, so you can easily understand that okay, it actually is true that this is giving something and theta both. So you know now, understand this very carefully. You know that expectation of this is this. Now you can replace. So idea is what you have to find out expectation of TCS, some function of x1 jiska, which is a jiska which is equal to what? Theta square, right? Therefore, you have to replace this by some function g of x1. How do you do that? By using this property. You see? So what do? You replace this theta by this. Let's do that. So what you do is that expectation of x1 square is theta square. Let it be theta square because we want to find some function of x1 square, and we replace this by this 2 by n times expectation of what? Plus 2 by n whole square. And what we get? This will be x square. Okay, no, wait, yeah. And we get what? If we add it, I think you will this get cancels, right? So we get that expectation of this minus twice x1 by n is theta square because this get cancelled, and therefore this is the f of x1, right? Which is the UMVV. Did you understand this, guys? The way out, how we are doing it? It's very, very important, guys. You're right. Very good. So Shantanu has a really interesting way. I will tell you that. So are you getting the same answer, Shantanu? Are you having the same answer, Shantanu? Very good. So this is the way out. So Mansi, Proma, did you understand this? What is the focus here? How we are trying to do that? Why we are trying to do that? Very good. So this is the idea. And you understand the complexity is exactly the same. Many times what will happen is that you will not find a way to do theta square. So if it's with the moments, okay, so often what you will find is that in one of the problems in IIT JAM, as I remember, there was a problem where I can do it next day, or I think it will discuss in our crash courses, where I think it's discussed in our crash course, where you have to find that u is a very use, like you have to find theta plus theta square aisa kuch tha, and it was indicated probability that. So that was really easy to find it out, and u was really easy to find it out. The idea is that we need to easily find out an u. Okay, you have to guess an u. This is the idea, and these are two ways of guessing. Did you understand, all of you? Nikhil, Mansi, Paulame, Proma, Shuprabho, do you understand this? The whole algorithm. This is the only algorithm, guys. Did you understand? Is it clearer? Thank you, Mansi. Okay, perfect. So I will just end with Shantanu's beautiful solution, and that is this. We could have avoided collecting that, but this is the idea is that xi's are all, if you observe, xi's are all shifted exponentials, and that means xi minus theta is exponential 1. Okay, so therefore expectation of x1 you can find out from this exponential only. So the minimum you can find it out, it will be 1 by n. So therefore x1 minus theta is nothing but 1 by n, and variance is nothing but 1 by n square. I'm sorry, 1 by uh, n square. Yes. And therefore from here you can easily find out the variance and this of this. So this is variance of x1. And anyway, you have to calculate for exponential only, which is same work, I guess, because you have to do that x, and that is the gamma integral what your Ptolemy was talking about. Here is shifted, so it's gamma integral again. So it's not. So you can also do it by gamma integral. That's also another way out. And here it's also expectation of x1 is theta plus 1 by n. So this is the whole way out. Okay. So let me just revise it. What is the idea? So one is CRLB. So I'm revising it by TCS. So TCS ka first step is finding the complete sufficient statistic. And we know we have discussed that. finding this, and then the two steps are to find an unbiased estimator. So what we can do is that we can find functions of TCS which is equal to expectation of which is equal to theta or g theta. Or if we can start with u, which is an unbiased estimator of g theta, and we can take, or maybe u dash, and we can take the new u to be expectation of u dash given TCS is equal to g theta. So this is the UU, which is the better, the UMVV. So these are only two way out, okay? And that's it. That's it. How do you find this? You need to find the distribution of TCS ka distribution. We need to find out and everything. So we need to find out how TCS behaves. Otherwise, we cannot find out this values, okay? We cannot find out the expectation of this. So we need to find out the TCS ka everything. So this is a complete way out, guys. So I took a complete problem. I showed you how to find the complete sufficient size and everything, okay, of an unknown distribution from scratch. That's why I didn't use Shantanu's method, because it would have been easier and you can relate it to something. But in IIT and these places, these things are really really easy and easy to understand and do, right? So I hope you understood this. I will not do more problems. And this is the only algorithm I want to share with you. Anything you want me to discuss on more, guys? Otherwise, I will just wrap it up. Yep. Anything you want to discuss more? Okay, I think you are. There's nothing more to discuss. And next day we'll be starting testing hypothesis problems. And okay, perfect. I hope you're confident in estimation now, guys. Better than before. So I've given you all the algorithms to solve this sufficiency, completeness, UMVV. These three are important, right? I've given you all the algorithms to find out. So that's it. So write it down in your cheat sheet and be prepared for the mock tests for statistics and like all the others. So all the best, guys, and I will see you in the next class. And yep, that's it. If you are enjoying our work, do subscribe, share, and and like it. Thank you, guys. Bye.